Ladies and gentlemen, welcome to today's event in the series of webinars hosted by the Green Growth Knowledge Partnership, or GGKP, under the Global Environment Facility 10785 Global NIP Update Project. Greetings, I am your webinar moderator today. My name is Jana Chuo, a knowledge management specialist working with GGKP on one of its Global Environment Facility technical assistant projects focused on chemicals and waste. Thank you for registering and joining today's Global NIP Update project webinar. This webinar is part of the training activities delivered by the GGKP under Component 4, Knowledge Management and Information Sharing of the GEF-funded NIPS project under the Stockholm Convention on Persistent Organic Pollutants, hereinafter referred to as the Global NIP Update Project. As part of these sharing initiatives, this webinar is the second of a series. To refresh our memory, the first webinar of the series was held last 16 December 2025 and was about activity options for action plans on the management and elimination of PCBs and POP pesticides. If you would like to access the first webinar in this series, please have a look at the chat box. My colleague Sumin will drop the link for you to review the recording. So on to today. Today's webinar will introduce action plan options for managing unintentional POPs or uPOPs and per- and polyfluoroalkyl substances, PFAS, listed as POPs. On your screen, you will see an estimate time for our agenda today. In context, developing action plans for POPs is essential for three reasons: managing and phasing out POP substances, avoiding regrettable alternatives, and meeting core obligations under the Stockholm Convention, including Article 15 reporting. Effective action plans provide the basis for sound POPs management by guiding exposure reduction, informing regulatory control, addressing national priorities outlined in the NIP, and supporting the preparation of elimination projects. For this reason, action plans must be well developed, technically robust, and reviewed by relevant ministries and stakeholder groups. So, in today's webinar, the specific objectives will introduce integrated approach to POPs management, and our speakers will also provide an overview of activity options for eliminating PCDD, PCTF, and other unintentional POPs. Also, to introduce broader approaches to substitute the group of PFAS, avoiding regrettable alternatives. In this slide, it's always a good idea to acknowledge the people in the room. An overview of our audience today includes Stockholm Convention official contact points and national focal points, particularly from our project countries, national officials and experts involved in the process of reviewing and updating NIPs. Members of the National Statistical Office and similar practitioners are present as well. Most importantly, representatives of regional centers and stakeholders are present. And now, I would like to give some housekeeping remarks. As always, our webinar will be conducted in the English language and is recorded. This event is supported with interpretation into French, Spanish, and Russian languages. Please feel free to select your language in the bottom of your screen. The event is technically facilitated by my GGKP colleague Sumin Bey. Once we start, please feel free to introduce yourself in the chat. It's a great opportunity to meet colleagues from all over the world. Now, ladies and gentlemen, let's start with a formal opening and welcome remark from Ms. Carla Valclan. Carla is a program officer responsible for national reporting at the Basel, Rotterdam, and Stockholm Convention. She is responsible for areas pertaining to the Basel Convention, technical guidelines, and electronic approaches to the notification and movement documents. Moreover, she has been with the Secretariat since 2010 and has a lot of experience in Stockholm Convention and POPs. Without further ado, Miss Carla, I hand over to you.
Thank you, Jana. Hello, everyone. Good morning, good afternoon, good evening, colleagues. I'm not sure where all of you are based today. Also, hello to the distinguished panelists, our experts who agreed to be here today with us. As Jana just said, I work for the Secretariat of the three agreements, Basel, Rotterdam, and Stockholm Conventions. And it's my pleasure to be here today to address some pressing environmental and public health related challenges that we all face on our daily basis. So specifically on this webinar, the issues around uPOPs and the coverage on the BAT and BEP and the broad spectrum of PFAS management. I think these are very important topics under the Stockholm Convention, and I'm very thankful to the GGKP for organizing this, as all of these aspects are important for those implementing the conventions, as I understand many of you attending this webinar are responsible for doing. On uPOPs, I think it's fundamental that parties and stakeholders implementing this convention, the Stockholm Convention, understand how these POPs are generated and ideally to avoid these practices. Now, uPOPs, as you may know, otherwise you're going to learn a lot today here, unintended byproducts during the manufacture of certain chemicals, but they are also released during waste management practices and like such open burning or poorly controlled incineration and other industrial processes. So parties and stakeholders need to work on identifying and quantifying uPOPs sources, and they need also to develop strategies to minimize and, where feasible, eliminate their releases. So I think Professor Harenberg is going to also cover the aspects of BAT and BEP, which fundamental under the convention, is a very important area of work. And there are many details, information, guidance available for all of you on this area. Now on PFAS, I think we never stop. No? As I normally joke, we can never retire. So in the case of PFAS, I think that proves my point. As you may be familiar with, PFAS is a group of POPs that represent a very extensive group of synthetic chemicals that have been part of our lives nowadays because they are embedded in many products and so on. And their structure makes them remarkably effective, like in applications such as water repellents and so on, and heat. But unfortunately, these same properties also make them extraordinarily persistent in the environment. And looking at recent scientific reviews, we learned that there are many links, potential links, let's put it this way, between PFAS exposure and several effects on our health, such as immune functions or metabolism or reproduction issues, and even development. So this is a very serious group of POPs that we need to tackle. And PFAS have become a source of contamination in many areas of the world, due to their ability, like several other POPs, to travel long distances, and they remain in the nature and the ecosystems for decades. So also these studies show that we can detect PFAS in water, soil, air, wildlife, humans, and this is reflecting exactly the problems that we are seeing. And for those who are not familiar, but I'm sure that Roland Weber will also cover that. So PFAS are now a part of many products that all of us use, such as non-stick cookware, our jackets, sometimes waterproof jackets or shoes, and also in other industrial products. As such, it's of ultimate importance for parties to the convention to advance the work, the knowledge, the work on understanding, identifying, and ideally eliminating PFAS from our lives. So I will stop here because I think we have a lot of things to learn from our two fantastic experts here in this webinar today about related information on these three topics, guidance, documents available and also tools that can help you tackle these issues. So I wish you a nice webinar, and thank you for taking the time to being here with us today. And finally, I would like to thank our organizers, our GGKP colleagues, and also the experts to their dedication to this work. Thank you very much.
Thank you so much, Carla. And like what you said, it's very important because, for example, like normal people like us, we know that PFAS is already in our lives and in our homes. So I think I will begin our first session with our first speaker today. He is a familiar face to NIPS, but most especially, he is the UN's most credible consultants for the implementation of the Stockholm Convention. Dr. Roland Weber has devoted 25 years of research on persistent organic pollutants. He has consulted for UNIDO, UNEP, UNDP, and of course the Stockholm Convention Secretariat. His main expertise includes POPs, brominated and fluorinated POPs as well, including BAT and BEP sustainable consumption and production. I could go on, but I think I will now give the floor to Dr. Weber to guide us through some basic considerations on action plan development and integrated approach. Here you go, Dr. Roland.
Yeah, thanks, Jana, for the kind introduction. Good day, everybody. Thanks very much for joining today's webinar. Our first presentation will be on some basic considerations on action plan development and especially the integrated approach. When we look today, we have 37 POPs listed in the Stockholm Convention. Many of them, the black ones, are chlorinated POPs, including most pesticides, and all of our unintentional POPs are chlorinated. And then we have 4 PFAS groups, which have a wide range of uses, which Carla already mentioned. These 2 groups we will address in today's action plan options. And the other POPs, the 5 brominated flame retardants, chlorinated flame retardants, and non-halogenated UV stabilizer, we will cover on Thursday in the webinar. Here is the link, and I think also Sumin will share the link in the chat for Thursday webinar. A friend of mine, Professor Scheringer, evaluated approximately 100,000 chemicals according the Annex D POP criteria of the Stockholm Convention, and found that rather more than 570 potential POPs are in production from these 100,000 chemicals. And today, many of these chemicals, which have POP-like or PBT properties, and many of them are used in consumer goods, like in electronics, in cars, in buildings, furniture, in textiles and synthetic carpets. So you see, they're really surrounding us. And these PBT in products pose a risk for human health, the environment, and also recycling and the recovery flows. Here, chlorinated, brominated, and fluorinated persistent toxic substances need to be assessed and managed systematically. And when you look to these 570 potential POPs, you see nearly 50% were chlorinated, 13% brominated, 16% fluorinated, and around 19% mixed halogenated. So we have now also these 3 groups in the Stockholm Convention, and therefore, with an integrated approach and cooperation with the Global Framework on Chemicals, we can look and manage chlorinated, brominated, and fluorinated persistent toxic substances all together if we do appropriate action plans and implementation. And the 100,000 chemicals which Professor Scheringer evaluated is also only a part. Today we have around 350,000 chemicals in production. And in the CAS register, we have more than 100 million chemicals, and some of them might go also into production. The OECD report projects that overall chemical production is expected to quadruple between 2020 and 2060. And therefore, I think also our efforts should at least double or better quadruple in respect to chemical management. Because these novel entities, chemicals and plastic, crossed already planetary boundaries. What are the planetary boundaries? They define the environmental limits within which humanity can safely operate. And they have been evaluated for 9 critical anthropogenic pressures on the Earth systems, and 7 of them have already crossed by 2025 the planetary boundaries. This includes climate change and biodiversity, but also the so-called novel entities, including chemicals of concern like PFAS and the plastic pollution, and therefore are of high concern for humanity and a risk for several ecosystem services and for the entire planet. Due to this, the United Nations highlights that humanity faces a triple planetary crisis of climate change, nature and biodiversity loss, and chemical pollution and waste. And there are interlinkages of chemicals and waste and other drivers of the triple planetary crisis. And where possible, we should address them in a synergistic manner. For example, there are strong links of chemicals and waste to climate change, open burning of waste, or management of plastic foams containing POPs, but also F-gases with high global warming potential, or chemicals including POPs or highly hazardous pesticides are relevant causes for biodiversity loss. For example, reduce reproduction of predators at the top of the food chain, like killer whale population collapse or eagle eggshell thinning. So therefore, Inge Andersen, the director of UNEP, highlighted that the toxic trail of economic growth, pollution and waste results every year in the premature death of millions of people across the world. And the WHO quantified this. WHO estimates that around 8 million deaths per year are attributed to pollution. A key impact we have here by ambient pollution and indoor air pollution, but also WHO estimates that the burden of disease from selected chemicals are at least 2 million lives. And the Global Chemical Outlook states that the life of many more are negatively impacted. So open burning and industrial emissions are the major sources for air pollution, additionally transport. And at the same time, open burning, like plastic waste as a major fuel, is also the major contributor for dioxin global emissions to air and is the top source of unintentional POP release in Africa, Asia Pacific, the Krulak region. And other major sources here for dioxins are waste incineration, this is here in blue, and the metal industry here in red. So these emissions also release small particles, PM2.5 and PM10, heavy metals, PAHs, and black carbon, which is a short-lived climate change pollutant. And if we are clever, we can address these kind of emission at once when we do our action plan for unintentional POP and related implementation. The Lancet Commission and the Global Alliance on Health and Pollution additionally state that also contaminated sites heavily contribute to exposure, and they estimate that this might be 1 more million premature deaths in addition to the air emission. So therefore, pollution is by far the largest source of death causes. When you look here, the second one is then tobacco smoking, but also actually tobacco smoking is chemical exposure and can be addressed by reduction of burning. The integrated pollution reduction here by linking of POP action plans with the wider national waste and chemical management and BAD-BEP can here first address the sources for major ambient air pollution, open burning, industrial emission, house heating and cooking, and emission from transport. So most of these sources and emissions can here be addressed by BAD-BEP and by waste management, and are all assessed by the unintentional POP inventory and by the action plan. Also, the major sources of indoor pollution, which is cooking and heating with fire, and hazardous chemicals in products and buildings. So these sources can also be addressed by BAD-BEP and by substitution of chemicals of concern. And the third, the contaminated sites, also mainly result from waste disposal and industrial releases and a lack of BAD-BEP and waste management. So here, an integrated approach of addressing unintentional POPs, heavy metals, particulate matter, PAHs, black carbon, within a larger frame of managing waste and chemicals and reducing industrial releases should be the top priority of our action plan. So a wide range of industrial facilities here emit dioxins and uPOPs. This include waste incinerators, here the emissions in blue globally, metal industries, here in red, mineral production, these are smaller overall, here in pink, and then power plants here in green. So they can all be addressed by the BAD-BEP, and we have a BAD-BEP guidance of the Stockholm Convention, which for each of these sources have an individual chapter. For the control of releases of dioxins and uPOPs from emission in Annex C, the guidance published in 2006 is updated continuously, and I will also reference to some of the updated chapters. The action plan and the NIP implementation can be an important impulse here for emission control in these major sources, especially when considering here an integrated pollution prevention and control approach of the industries. And when you look here to the general principles and cross-cutting considerations of the BAD-BEP guidance, here the BAD-BEP guidance highlight the integrated pollution prevention and control approach, and also the waste hierarchy. And this integrated pollution prevention and control, or so-called IPPC approach of releases from industry, is considered by BAT reference documents of the European Union. And therefore, we have invited today Professor Harald Schönberger, who will give us an overview of this. Here, just one case study that you understand the importance. So this is around a steel plant in Italy. And around 2009, dioxins and PCB contamination were discovered in meat and milk. After that, 1,600 sheep and goats need to be slaughtered and incinerated. They could not be eaten because of dioxin and PCB levels. And then since 2012, there is a 20-kilometer restriction zone for cattle. In addition, it was found that high cancer rates in humans exist in humans. And a question is, what is here the impact of dioxins and PCBs? And what is the role of other pollutants? Because yes, we from the Stockholm Convention, we focus on dioxins and uPOPs, but that's here a comic from Professor Takatsuki from Kyoto University, who say, why that guy getting all the attention and arsenic and mercury and other heavy metals are complaining about that. So here it is necessary to look to an integrated approach, and I just show you here the total emission of pollutants from this primary steel plant. So in total per year, this steel plant has 100 gram TEQ emission. So this was sufficient to contaminate the surrounding. You have seen over 10 kilometers, total 20 kilometer in diameter. And when you look to other contaminants, you see this plant emits 230 tons of benzene every year. Benzene is a cancer causing agent category 1. also emit more than 33 tons of PAHs. Also PAHs are cancerogenic. Then the plant emit to the air, that's only to the air, 80 tons of lead, 4 tons of chromium, 1.5 tons of mercury, half ton of cadmium, and 5,380 tons of particulate matter. Yeah. So the emissions of this plant were reduced in the last decade. However, there are recent publications and documentary which still report on the increased death rates and cancer rates in this area, also in children. So I have compiled here some of the recent publications, and actually just in the beginning of this year, there is a documentary, a 10 minutes documentary I would recommend you to watch on YouTube, which highlights here the contamination of children, or the increased cancer rates of children in the Italy case, and another case in the United Kingdom of a similar plant. So therefore, it is important to come with an integrated approach. And this is also stressed by our National Implementation Plan update guidance. The development, review, and updating of a NIP should build on existing work and assessment, and therefore POP should not be addressed on their own, but should be linked and integrated with general chemical and waste and plastic management. This may include a national chemical profile, national GHS implementation, plans and strategies, national chemical and waste management plans. Of course, the synergy between Basel, Rotterdam, Stockholm, and Minamata Convention. I will come back in the presentation sometimes to the Minamata Convention and the link to synergies to release reduction of heavy metals, as you have seen, synergies with greenhouse gas reduction, open burning, but also from these facilities by BAD-BEP, you can reduce greenhouse gases by increasing the efficiency of the plants, and linking to issues of concern of the global framework on chemicals and related synergies. So when we look here to the issues of concern of the global framework on chemicals, we see that actually there are very strong synergies between Stockholm Convention and the GFC. Highly hazardous pesticides we have addressed last in December in the webinar, where you have the link. In this webinar, we have the POP-PFAS, and here as issue of concern in the GFC, you have perfluorinated and polyfluorinated alkylated substances and the transition to safer alternatives, chemicals in products, hazardous substances within the life cycle of electronics and electrical products. So that will be part of the webinar on Thursday. And also endocrine disrupting chemicals. Basically, all POPs are also at the same time endocrine disrupting chemicals. Here, the specific POP issues can and should be addressed within the larger frame of managing a wider group of POP-like and other hazardous substances with a science-based approach. And I will come to this today in the PFAS presentation. Coming to the action plan. So when you are writing your NIP, in chapter 3, there is the strategy and the action plan elements of the National Implementation Plan. First, the NIP update guidance suggests to have there a policy statement, then the implementation strategy. And I recommend you that for the implementation strategy, you can use this section to elaborate on the integrated approach, including how the NIP links and can contribute to national chemical management and national waste management, including also plastic management, and also the link to sustainable consumption and production, circular economy, and One Health can be elaborated here. In chapter 3.3 are then the activities and strategies and action plans. Here would list country-specific actions and activities and strategies, including those required by the convention and designed to meet the Stockholm Convention obligation. So each action plan would identify objective goals and activities. And when you go to the NIP harmonized template, which is online, it also contains a template for action plans. And here you see it considers objectives, activities, performance indicators, timeframes, and implementers, and possibly research needs. So in today's webinar, we will come to the options for objectives and activities for the action plans for dioxins and other unintentional POPs, and fluorinated POP-PFASs will be introduced in the next 2 hours. So this is, let's say, a bit introduction to the integrated approach. And I don't know, Jana, if you already have a question which we could have a look at, or should we continue directly with the second presentation?
So far, so good, Roland. I don't see any big question. Sumin, can you confirm? Maybe in the Q&A? Okay, I think we can continue.
Okay, good. Then we come to the action plan options for reduction and elimination of unintentional POPs and considerations for an integrated approach. So 4 of the regional 12 POPs were unintentional produced, including the polychlorinated dibenzodioxins, PCDDs, and the polychlorinated dibenzofurans, PCDFs. Also, polychlorinated biphenyls, PCBs, are unintentional POPs, but overall the main amount were intentionally produced PCBs. But in this presentation, you will also see that this is changing and that the unintentional PCBs become more relevant. And also hexachlorobenzene can be unintentionally produced and also can be have been produced in the past intentionally by industry. 2009 pentachlorobenzene were listed, in 2015 polychlorinated naphthalines, and then in 2017 also hexachlorobutadiene were added to Annex C. These POPs are commonly formed as byproducts in the production of organochlorine chemicals, in processes where elemental chlorine is present, and also in thermal processes in the presence of all forms of chlorine. What are the synergies in addressing unintentional POPs? So the first is that the reduction of dioxins from sources reduce at the same time also other unintentional POPs. So therefore, often when we do an inventory, but also for the measures, we focus on dioxins in most activities, and at the same time, by this action, also other unintentional POPs are reduced. But the reduction of dioxins and uPOPs from incinerators or metal industries can at the same time reduce heavy metals, particulate metals, PAHs, and also black carbon. I will come a bit to that. Also, the reduction and control of open burning reduce at the same time particulate matter emissions, PAHs, black carbon, and other releases. And similarly, reducing indoor cooking over an open fire, optimizing stove design and ensuring the use of suitable fuels result in the reduction of dioxins, other unintentional POPs, but also particulate matter and PAHs, and therefore indoor pollution reduction. For an appropriate risk assessment and cost-benefit analysis, because sometimes when you suggest a bad measure, it costs money, then industry might ask for a cost-benefit analysis. So these other reductions need also to be considered. In some cases, like open burning of biomass, which releases high amount of particulate matter, high amount of black carbon and PAHs, this impact of co-pollutants is more relevant than the uPOP emission, which overall from normal open burning of biomass is relatively small. Also, black carbon, which is a short-lived climate change pollutant, contribute to global warming. Therefore, also here synergies exist between uPOP reduction of global warming, and also this should go into a cost-benefit analysis. When we look here to the main emission source, especially for low and middle income countries, the action plans for unintentional POP is an opportunity for promoting and addressing general management of waste, and basically the reduction of open burning of waste as major source of unintentional POP and other pollutants can only be addressed by improvement of general waste management Yeah, so this is also at the same time key for management of POPs in plastic. And general reduction of industrial emission from these large source categories listed in Annex C by POP-PFAS. Also at the same time can address these other pollutants. We will come to that. So this is just the slide you saw from the Italy and the air emission. So if you install in such a facility a BAT filtration of air emissions for reducing dioxins and other uPOPs, at the same time you reduce heavy metals and particulate matter. And if you use then also activated carbon spray, then also you can even reduce the relatively high volatile mercury together with the dioxins. And UNEP highlights that the global exposure risk to toxic metals and metalloids, lead, cadmium, arsenic, and organotin, is inadequately addressed. Because at the moment, when you look to the global conventions, we only have the Minamata Convention on mercury. So therefore, UNEP published just in recently in the 7th session of the UN Environmental Assembly a report on options to address lead, cadmium, arsenic, and organotin pollutants. And here the smelting industry are significant contributors to the environmental contamination, often releasing especially heavy metals and other pollutants in the surrounding. And the measures here of our dioxin and the action plan on incinerators and metal industry can here reduce these source and this concern of UNEA 7, because it will take probably years that, let's say, UNEP can establish a real program on these other metals. So therefore, our action plan of unintentional POP is a good chance to address major release sources of these metals at the same time with unintentional POPs. And there is a specific synergy between unintentional POPs and mercury. When you look here, this is the guidance on best available techniques and best environmental practices from the Minamata Convention on mercury. You see that all thermal sources in the Minamata POP guidance, these are smelting, coal-fired power plants, waste incinerators, cement kilns. They are at the same time also high priority sources and included in the uPOP POP guidance. And when you look to make major techniques to control unintentional POPs releases, this is, for example, activated carbon spray for these facilities or other adsorbents, or using specific wet scrubber, can at the same time also reduce and control the mercury releases. So therefore, yes, the guidance highlight this integrated pollution prevention and control approach. And just one slide here on the European Union integrated approach. Here for the European Union, the integrated approach means considering all aspects. This means all pollutants, particulate matter, heavy metal, acid gases, and the dioxins are only one of the parameters. Also consider emission to air, water, soil, and land. Include occupational health aspects and noise, energy aspects, monitoring of POPs, of pollutants. And for all these sources, the metal industries, the incinerators, power plants, there are BAT reference documents from the European Union, and Professor Schönberger will give you an introduction. So coming now to details of the action plan, and I always start in action plans with the regulatory framework because that's key. Without regulatory framework, normally nothing really moves. So the objective here is to establish a policy and legal framework for reduction and minimization of unintentional POPs. And recommended activity options are: first, undertake law and policy assessment on dioxin and other unintentional POPs. This means an assessment of your own national policy and law situation, and then also look to other countries, how they control and manage unintentional POPs. After that, amend existing laws or develop new laws as appropriate, related to the management of dioxins and other unintentional POP, possibly within an integrated pollution prevention and control approach. Development of release limit values or performance standards for unintentional POPs or surrogates in the frame of general emission limits. Then setting unintentional trace contaminant limit for unintentional POP in chemicals, mixtures and products, and assess the need and possibly develop standards and limits in major media considering relevant for the country. For example, in Europe, we have regulatory limits for dioxins and dioxin-like PCBs in food and feed. In Germany, we have limits for soil and also for chemical products. Then develop first, when we look to develop release limit values or performance standards of unintentional POPs or surrogates in the frame of general emission limits. The background is that low-income countries often do not have the sampling and analytical capacity of dioxins. Yeah, so therefore, also when you set then a dioxin limit in your facilities, it's quite difficult for you to implement it, to monitor it. To get a sampling team from abroad is often more than $10,000, so it's a real burden for the industry. I would like here to show you one approach from Switzerland, which is known as a country with strict environmental guidelines. And also Switzerland did not set explicit limits for dioxin emission until 2008. Until that time, they had an alternative dioxin control policy. The dioxin emission were minimized by setting stringent limits for dust emission and heavy metals, as well as standards for combustion quality. Yeah. So here, for example, they have a relatively low carbon monoxide limit of 50 milligram per cubic meter. At the same time, there you need then to have a good combustion quality, and the good combustion quality reduce the dioxin formation overall. The same with the total organic carbon limit. Also, when you limit here the dust emission to 10 milligram per cubic meter or even 5 milligram per cubic meter and limit the heavy metal emission, at the same time, you also control the dioxin release into the environment. And if you then set the right temperature of a dust filter, which should normally be below 170 degrees to avoid dioxin formation and to increase adsorption, then this is an effective strategy for dioxin emission control for incinerators. Yeah? This will often not result in a dioxin emission of 0.1 nanogram TEQ, which is considered BAT. But let's say for most of the facilities in developing countries, if they would meet less than 1 nanogram TEQ, which you might achieve with this, let's say with these parameters, you could also work with this until you have that kind of capacity. Advantage also of these parameters is that they can be better controlled. Yeah, because for dioxins, maximum you can have one measurement per year. Yeah, 6 hours. Yeah, so here with carbon monoxide or NOx or dust emission, you can also do continuous monitoring. Then another recommended activity options where I go into more detail is to set unintentional trace contaminant limits, so-called UTC limit values for unintentional POPs in chemicals, mixtures and products. So here the European POP directive sets unintentional trace contaminant limits and low POP content limits. Here, very recently for PCBs, the EU developed a draft legislation which will enter into force and could be considered by other countries. Here, the UTC limit value is set to 0.2 milligram per kilogram and will be set for the sum of PCBs in substances, mixtures, and articles. This is quite low. But there is one exemption because for some pigments and dyes, they are above the 0.2 milligram per kilogram, but some of them, of these pigments were considered relevant, and therefore specific UTC limits of PCB mixtures and articles containing organic pigments or dyes were set to 25 milligram per kilogram. And 3 years later, this limit will be reduced to 10 milligram per kilogram. This is relatively low for some of the dyes. So I have seen Japan have done measurements. They have found some of these organic pigments with 1,000 and 2,000 milligram per kilogram, have set 50 milligram per kilogram as a limit of pigments which cannot be used. So Europe is now further decreasing. And this was in discussion with industry, that the industry can meet 25 milligram per kilogram and further than in 3 years the 10 milligram per kilogram. I have put you the link to this draft, EU draft of unintentional PCBs. Also, already since a few years, the European Union POP directive has a UTC limit for hexachlorobenzene of 10 milligram per kilogram. Also, this is relevant for a range of chemicals, including some of the pigments. Then we look one time to unintentional trace contaminant limits for dioxins in chemicals, mixtures, and products. The background is that the Basel Convention low POP content limit of 1,000, 5,000 or 15,000 nanogram TEQ per kilogram is much too high for an unintentional trace contaminant limit in products. Yeah, so therefore countries set regulatory limits for products with dioxin release and exposure. One example is here Germany. The German authority discovered in a project where I was also part of it, that already a level of 5 nanogram TEQ in soil can result in dioxin contamination of eggs in free-range chickens above the EU maximum limit. And therefore, Germany have updated the fertilizer regulation with an unintentional trace contaminant limit of 8 nanogram TEQ and 30 nanogram TEQ, depending on the application. Another example is for pesticides. So certain pesticides can contain high levels of dioxins if not controlled in the production. So the Japanese authorities set regulatory limits for dioxins here for 100 nanogram TEQ per kilogram for each of the 2378 substituted dioxin congener already in 2002. And we have done a study in Australia and with a colleague, also a study in China on dioxin in some pesticides. And we have found, for example, that the quintosine, this is pentachloronitrobenzene, the levels of all formulations which we analyzed in China and in Australia were above the Japanese regulatory limit. And actually the Australian and also the Chinese regulators both have stopped the production and use of quintosine. There's also, I think, one regulatory gap. So this slide is a kind of food for thought. The US EPA, FDA screened some pesticide for their dioxin content and their dioxin-like toxicity with bioassays. So what they have found is 2,4-D pesticides. They found relevant dioxin levels with high-resolution GCMS. But they also measured these pesticides with bioassays. And yes, also for the 2,4-Ds, they found even a higher dioxin-like toxicity in these 2,4-D formulations. But the reason why I say this is a gap is especially of these two pesticides, Pronate and Azure 2. So they did not have any chlorinated dioxins, and you would not expect chlorinated dioxins here because they don't have really a precursor quality, but they had very high dioxin-like toxicity with the bioassay. Yeah, this means these were somehow brominated aromatic dioxins or dioxin-like compounds, which were had a dioxin-like activity. So hopefully we will get the brominated dioxins in the convention. And also when you look here to the structure of this pesticide, you see here we have a heteroaromatic compound and one chlorine, but also here a quite high dioxin toxicity, the same like the 2,4-D here. But also at the moment, we do not have a regulatory, let's say, handle to address these. So I think this is a kind of gap, and I give this to you as a homework. What is the appropriate regulatory approach to regulate these dioxin-like substances? One overview slide on this dioxin limit in fertilizers in Germany. So here, the 8 nanogram TEQ is especially for pasture land and for farmland without plowing, because there with 8 nanogram, when you apply this for some years, you might come direction of the 5 nanogram. With plowing, it will take very long time that you come to 5 nanogram TEQ in the soil. So therefore, for agricultural soil with plowing, they set a limit of 30 nanogram TEQ. But you see, these are orders of magnitude lower, of course, compared to the Basel low POP content. And also, for example, ashes from biomass are at the same time considered fertilizers, or are used to agriculture. And here the high Basel low POP content is basically misleading authorities in respect of managing ashes and waste, especially when we now think that there is more push to a circularity. We need to rethink, especially when these, let's say, dioxin impacted flows are reused and recycled. That's just one example here from IPAN, from their egg monitoring here in Indonesia, where they were plastic waste combusted in boilers, producing tofu and so on. And the ashes, which had levels of around 120 to 1,300 nanogram TEQ, they were around these boilers, and chicken had access to them. And the chicken eggs were several orders of magnitude higher compared to the regulatory limit in the European Union. But these ashes are still 10 to 100 times below the Basel upper provisional low POP content limit of 15,000 nanogram TEQ per kilogram. So you see, from all these kind of incinerators, the ashes need to be managed appropriately, not to contaminate the environment and your food. Now we come to 2. Always the second one is updating inventories, here for dioxin and unintentional POP. The recommended activity options are regularly update unintentional POP inventories every 5 years, along with review of strategies and reporting. Incorporate new listed unintentional POPs where appropriate. Like I said, for most of the sources, dioxins are sufficient, but especially in the chlorine industry, there are some production processes where we also need to look to other unintentional POP, because dioxins are low in those, while other unintentional POPs can be high. Also quantify other co-pollutants where appropriate, like the particulate metals, heavy metals, PAHs, carbon black, what I have shown you with the example of the steel plant. Then develop a mechanism ensuring appropriate storage and management of the data. Develop of a mechanism ensuring appropriate storage and management of the data. Develop of an integrated database of pollution release, including unintentional POPs, mercury, and greenhouse gases, because for many sources there is a overlap. Evaluate the option of developing a pollution release and transfer register. It's quite a challenge, but there are UNITA activities for this support. And Katka Sepkova from Racetox in a recent YouTube at GGKP has introduced here to a PRTR. And I have included the link for you to have a look. Now coming to the individual sources, first looking to open waste burning, then to waste incinerators, then to the metallurgical industry, and to heat and powers. So first, reducing of unintentional POP by integrated waste management and the waste hierarchy. The objective is here to reduce unintentional POP release from open burning of waste, including private open burning and landfill fires, and also from biomass burning by improved waste management. And the recommended activity options are here first the update of the National Waste Management Plan and Strategy, including promotion of the waste hierarchy and the circular economy, and here integrating unintentional POPs and POPs within the National Waste Management and Chemical Management Strategy. Develop a waste catalog and related management options, implementation of sound management of waste, considering the waste hierarchy with an increasing focus on prevention, reuse, recycling, and recovery in order to move towards a more circular economy. Then evaluate the co-incineration capacity. In particular, you can look in many countries, you have cement kilns in the country or in the region, and establish co-incineration for waste which cannot be recycled. Especially you will see in the next webinar on Thursday, we have now huge amounts of plastic waste which contain POPs, and where at the moment there are hardly any other options if you don't want to put this to landfills, but in landfills often you have the open burning with the releases. So therefore this co-incineration might be one interesting activity option. Then to the landfill fires. When you look into recent years, we had major landfill fires in Chile, Mauritius, Myanmar, Serbia, and avoiding of such fires need to be a key activity, because during one of such landfill fires, huge amount of pollutant can be released. We have done, or UNEP has done a study with Serbia. I have put you here the publication on it. And the recommended activity options are assessment of available guidance for the closure of dump sites, adaptation of national situation, closure of dump sites and prevention of illegal dumping of waste, including fines, awareness program for landfill operators on the impact of open waste burning, as well as an educational program on fire control, construction of engineered landfills for remaining waste disposal, and awareness programs and fines for this open waste burning in backyards. So here, for this landfill closure, there is a very good guidance from ISWA, International Solid Waste Association, and they have published already 8 years ago a roadmap for closing waste and dump sites, which is quite detailed. And what you see here, there are also already national guidelines here for Sri Lanka on the safe closure and rehabilitation of municipal waste. And I have put you here both the links. And when you look here to this ISWA guidance in the annexes, there are alternative financing instruments for waste management and for landfills, alternative cost recovery options for waste management, and then details like cover design types and site allocation criteria and so on. Yeah, so these are two very good documents for that activity. Coming to open burning of biomass and landfilling of organics. So the objective is here to reduce releases from open biomass burning by improved national biomass management, including a biomass strategy. Activity options are here: assess and develop approaches for reducing open biomass burning, development of a national strategy for biomass use within the National Waste Management Strategy, promote and implement the strategy by using biomass, including agricultural residues, and the options are here either production of compost and organic fertilizers and others, black soldier flies, for example, for also energy production like biomass boilers or biogas. And then something innovative is consider and implement biorefinery concept as appropriate. This means really to think not only to make fuels, but even to make solvents or bulk chemicals or even plastic from biomass. Yeah, and especially here for plastic, you see that there are already some plastics produced from these and often biodegradable plastic from this biomass. Then we come to action plans for waste incinerators. The objective is here to reduce and minimize releases of dioxins and other unintentional POP from waste incinerators and improve medical waste management. In many developing countries, the medical waste incinerators are a major source, so therefore medical waste management is here also a key for the action plan. So first recommended activity options are assessment of the reduced potential of total amount of waste incinerated towards a more circular economy but at the same time, when we are improving here the circular economy and improved recycling, of course, we need to avoid recycling of chemicals of concern. Yeah, so here this need to be balanced. Assessment of available BAT-BEP guidance documents and adjust to national circumstances. You see here, we have a section, of course, in the Stockholm Convention BAT-BEP guidance, but also we have the Basel Convention technical guidance, D10 R1 on waste incineration, and we have the BAT reference documents for incinerators of the European Union. And then action, implement BEP, best environmental practice, and where required, best available techniques in existing waste incinerators, including medical waste incinerators, and require BAT for new incinerators. Yeah, because after 4 years enter into force for new facilities for such Annex C Part 2 sources, BAT is required. In respect to medical waste, assess of technology to treat medical waste and select and implement of sound treatment methods, including non-combustion technologies. Develop national guidelines for sound management of medical waste. And here I would like to refer, we have here older Basel technical guidelines, but we have here a big safe management of waste from healthcare activity blue book from WHO, which you can use. Then strengthen institution and human resource capabilities to implement environmental sound management of medical waste. And now coming to metal industries. Metal industries are also major emitter of dioxins. Here you see the red ones are the emissions from metal industries. You see, for example, for East Europe, Central Asia countries, it is actually the major emitter. So when you have, and also metal is key for circular economy. So therefore, in the coming years, metal recovery and secondary metals will increase. The objective is here to adapt BAT-BEP and integrated pollution prevention and control as appropriate in the ferrous and non-ferrous metal production to reduce and minimize releases of dioxins, other unintentional POP and other priority pollutants. First, assessment of metal recovery rates and losses, as well as gaps for the circular economy. Like I said, we at the moment, we do not have really a global approach on managing these metals. And a large amount of these metals is lost. Yeah, so therefore I propose in the action plan here for the unintentional POP action plan to do an assessment of the metal recovery rate and to understand how good you are in respect to circular economy of metals. Then to develop or promote institutions that have the technical capacity to support the implementation of metal recovery and BAT-BEP, implement BAT for new Annex 2 sources like secondary alumina, secondary copper, secondary zinc, as well as sinter plants, and promote the use of BAT and BEP for existing sources and for sources in Annex C, Part 3 of the Annex. Also here, from the Basel, we have a technical guidance on environmental sound recycling and reclamation. And from the European Union, we have a BAT reference document, different BAT reference documents for the metal industry. Professor Schenberger will come to the more details. Coming to power plants, action plans to power plants. background is combustion for energy production is a source of unintentional POPs, greenhouse gases, mercury, and particulate matter. The objective is to adoption of POP-PFAS and, as appropriate, integrated pollution prevention and control for fossil fuel-fired boilers, firing installation for wood biomass and residential combustion, and switch to alternatives and renewable energy sources. So here activities are promote the use of POP and PFAS for fossil fuel fire utility and industrial boilers, as well as firing installations for wood and other biomass fuels. Also here we have a BAT reference documents, and very important and happening, especially under the frame of the Climate Change Convention, substitute fossil fuel power plants with renewables. So that's happened, and it's a good synergy between Stockholm Convention and the Climate Change Convention. Then reduction from indoor cooking and heating with biomass. The background is indoor heating and cooking with coal, charcoal, and wood result in indoor air contamination with health effects that contribute heavily to the global burden of diseases. It's estimated that about 3.7 million premature deaths are occurring from indoor air pollution. And also the state of access to modern energy cooking services report from the World Bank from 2020 states that around 4 billion people around the world still lack access to clean, efficient, convenient, safe, reliable, and affordable cooking energy. So therefore, the objective is to improve stove performance, phase out open fires, and support alternatives to wood, charcoal for household heating and cooking. And the first step, it can be the promotion of improved cooking stoves, but it is rather seen as an intermediate solution. So the substitution to substitute cooking and heating with fossil fuels by renewable energies should be a priority. And this is already happening. And there are big activities in Africa, but also in Asia to do this switch. And it can be facilitated by the action plans, but often it also comes rather from climate change activities. But here, like I said, it's a synergy. Then there are some other Annex C sources. So unintentional POP from other Annex C sources are reduced and eliminated by POP-PFAS. One is the substitution of elemental chlorine in remaining pulp and paper industries by alternatives. This means substitution of elemental chlorine. And we have updated that guidance documents from Stockholm Convention. And what we have found that actually most of the pulp and paper, for example, in China, all of the pulp and paper has already been substituted. And in India, already the substitution has progressed. Then, and only a few are remaining. Then apply POP and PFAS to shredder plants for the treatment of end-of-life vehicles and electronic waste, substitute the smoldering of copper cables by cable stripping and by cable chopping. And then we come to the larger area of reduction of unintentional POPs from specific chemical production processes and substitution of chemicals and materials. So the background is that chemicals such as pesticides have been major sources of dioxins and still can contain dioxins. Unintentional produced PCBs in pigments and dyes and other organochlorine productions are major PCB sources today. And also for hexachlorobutadiene, we have seen at this dioxin conference in 2025 that the levels in the Arctic air are really high and are actually increasing over the last years. So therefore, we need to take action, and these are especially for the countries which have large organochlorine production. So here the use of substitutes or modified materials, products and processes to prevent the formation and release of chemicals listed in Annex C. The recommended activity options are identify the production and use of chemicals containing unintentional POPs, for example, certain pigments, certain pesticides, triclosan or certain secondary HCl, and evaluate their unintentional POP content, release resulting in contamination and the risk. So here you can start and look into the toolkit, but also the BAT guidance section is here updated for the chemical industry, and I would recommend you to have a look into that. Then identify and promote feasible and affordable alternatives to chemicals and materials contributing to unintentional POPs. And here I just show you here the findings of recent studies for PCBs. So here, this is one study from China. And here the study found that today, when you look to the pattern of PCBs, that unintentional PCBs are by far the highest PCBs in the environment in China. And this paper from a North American group, they even said, question, is current generation of polychlorinated biphenyls exceeding the peak industrial production of the 1970s? Yeah, quite interesting. So here we see large amount of PCBs in pigments. So the recommendation activity option is promotion of alternatives to chemicals containing unintentional PCBs. And one are these pigments. And there is actually a website in the United States on safe and circular inadverted PCBs, pigments, where you can look to the different pigments which contain dioxins and to the alternatives. And also a catalyst in silicone production can be substituted, and by this substitution you can reduce the PCB release from silicone production. Another option here is for the reduction of hexachlorobutadiene. The major source of hexachlorobutadiene is actually chlorinated solvent, especially perchloroethylene and trichloroethylene production. And here, by substitution of perchloroethylene in the cleaning of clothes with alternatives, and the substitution of perchloroethylene and trichloroethylene in degreasing of metals, this production can be reduced. So it's not only the production here, but also the use, which can reduce. And I recommend you to look here into a publication we published some years ago with the Stockholm Convention Center in Barcelona, how to prevent the use of toxic chemicals in the Mediterranean, where this kind of substitution is included. Another case where a substitution of triclosan reduce in the reduction of dioxin is here triclosan, which is used for soaps and also for toothpaste. So the recommendation is here to eliminate the use of triclosan in consumer products because there is no additional benefit. Yeah, so a normal soap kills your viruses and does not need an additional biocide like triclosan and the dioxins for that. Then major stakeholders. Now we come to awareness raising and education for relevant stakeholder groups on dioxins and other unintentional POPs. The objective here is that major stakeholders are aware and know the fundamentals on dioxins, other uPOPs and other major pollutant releases from Stockholm Convention Annex C Part 2 and 3 sources. First, to develop education and awareness material on health and environmental impact of dioxins and other uPOPs and other co-pollutants. So you can use my presentation also as part of this awareness raising. Then raise awareness among stakeholders and the public on the environmental and health impact of dioxin and other uPOPs and human exposure from emissions, contaminated sites and food. Conduct awareness and training for stakeholders on legal issues of dioxins and other unintentional POPs, because it's quite complicated to set legislation. Run awareness raising campaigns on dioxins and other POPs and pollutants of concern for relevant stakeholders and sources, such as industrial sources, incinerators, and open burning. So a good example are here the awareness raising materials from IPEN here on their X studies or our review articles, where you can have really a good overview. And from these, let's say you can make good awareness raising materials and communication. And as second last activity is then to establish monitoring of dioxins and other unintentional POPs and related relevant pollutants from Annex C Part 2 and 3 sources and human exposure. First, an assessment of the need and the options for monitoring dioxin and other unintentional POP from industrial priority sources and for human exposure. This means, do you have such facilities already in your country or in neighboring countries? Then, if not, establish international cooperations or strengthen the national capacity for uPOP monitoring, evaluating instrumental analysis and dioxin bioassays for potential use in countries. I see, especially in the bioassays for dioxin, a good potential for developing countries, because I see that in many developing countries, instrumental analysis, especially high resolution, face big challenges. And then, as next step, do the monitoring of these priority sources and also monitoring of priority foods and environmental samples. Last part is on uPOP contaminated sites. The background: dioxin contaminated sites are large legacies of the past nearly 200 years of industrial releases. Dioxins are highly persistent, and the generated contaminated sites have the potential to impact human health and the environment for long periods and many generations. Article 6 of the Convention says that parties shall endeavor to develop appropriate strategies to identify POP-contaminated sites, and if remediation is undertaken, then in an environmentally sound manner. To minimize the impact on vulnerable population and current and future generation, it is important that dioxins and other uPOP-contaminated sites are identified, inventoried, and assessed to evaluate the need for securing and possibly remediation. In our study on the review of contaminated eggs, we have found that close to 90% of the eggs around pollution sources like incinerators, metal industries, and so on were contaminated. So this shows the dimension, especially in developing countries, but also, you know, in the past, our metal plants in the 1950s, 60s, 70s were emitting high levels of dioxin. So also there, in areas and cities where we had these metal smelters in Germany, we can actually not have chickens outside. Another big source where these applied pesticides, this is an example from Japan. Japan has done the only inventory of the dioxins in pesticides in historic use. They have found that 460 kilogram TEQ of dioxins were released in the Japanese environment in the 1950s, 60s, and 70s, early 80s. And these dioxins are still there in the soil, in sediments, and even in sediments in the ocean. And this 460 kilogram TEQ you can compare to the global total release of around 100 kilogram TEQ of all sources from all countries combined. Yeah, so these kind of large sources from this historic application of pesticides is one. Recommended activity options for contaminated sites is develop update legislation to set criteria for determining contaminated soils and sediment, establish legislation on polluter pays principle for contaminated sites, consider guidelines for identification and assessment of sites contaminated with unintentional POPs. Here we have a good chapter in the dioxin toolkit, but also we have a recent POP guidance. I will come to it. Then education and training in identification and management of contaminated sites. Establish conceptual site models of potential uPOP contaminated sites. Develop a database and prioritization of the sites for further assessment and management, and assess and monitor of uPOP contamination and major co-pollutants for identified localization. So this is the link to our new POP guidance from the Stockholm Convention on POP contaminated sites. I recommend you to download and to have a look. And this is a good example of a database. So here for the Caribbean, they have developed a regional database on POP contaminated sites with GPS coordinates, name and information on facilities, nearby sensitive areas, GIS-ready format. So I think a very good example. And it was also introduced in a recent webinar from GGKP. I have put you the link. And also for these contaminated sites of uPOP, there is synergy with mercury. especially for chloralkali production sites and for PVC production via the acetylene pathway. There is dioxin release and pesticide release. So here I have you the link of a session we had 2 years ago, a quite good session on the topic of mercury and unintentional POP in a session. And I just show you here one example of a chloralkali contaminated site and dioxin contaminated site from Finland. Here from a chloralkali operation between 1940 and 1984. Also, they produced pentachlorophenol. Today in this river, we find 30 kilogram of TEQ. 12.8 kilogram TEQ are still remaining in the river. 12.4 kilogram TEQ have already migrated in the Baltic Sea. So you see these dioxins from the 1940s, they are not gone. And from the 1950s, 60s, 70s, they are still there. Yeah. So therefore, it's important to understand the history because the dioxin emission at that time was much larger. This facility also has emitted 30 tons of mercury into that river. Yeah. 2.7 tons are still in the river, 28 tons are already in the Baltic Sea, contaminating the fishes there. And these old sources we need to understand when we want to understand the pollution of today. Other recommended activity options for contaminated sites is developing a strategy for environmentally sound management of POP contaminated site, secure contaminated sites considering priority ranking and the need to stop exposure, identification of cleanup measures and initial cleanup procedures for high priority contaminated sites, and develop monitoring for contaminated and also the secure sites. Thank you for your attention. Do we have questions?
Yes, Roland, we have a few questions, but
Okay.
I think we let you catch your breath. That is such an amazing and intense presentation. For my own purposes, I come from an island nation. I'm originally from the Philippines. And triclosan is something that was it's popular. And now I realize it's a source of uPOP. So special shout out to the island nations here from the Dominican Republic and the Bahamas of the Caribbean. I agree with Dr. Roland. That database is very important. So colleagues who are attending this call, the national action plans that you're doing are very important. And to some of the concerns, yes, Dr. Roland's presentation and recording will be shared to you after this webinar. So don't despair. Oh, that beautiful talk that Roland gave us is recorded and you can look at it again. And speaking of which, Roland gave mention to our second speaker. So now I will introduce him because I think some of the questions raised by our colleagues here might be answered in his presentation. He will be talking about BAT-BEP for unintentional POP reduction to integrated pollution prevention and control of pollutants to tackle the triple planetary crisis. This is very important for us environmental scientists and practitioners in the field. But first, let me introduce Dr. Harald Schonberger. He is the head of the Chair on Urban Water Management and Water Recycling at the University of Stuttgart. He has worked on industrial pollution prevention and control at the Environmental Department of the Regional State Governmental Office in Freiburg, Germany for at least 10 years. So his expertise really covers permitting, inspection, and enforcement of large industrial installations that fall under industrial emissions directives such as textile finishing industries, chemical industries, iron and steel industries, paper mills, and electroplating plating industry. So, without further ado, Professor Schonberger, over to you, sir. Sir, you are muted. Please unmute your mic. Thank you.
Now you can hear me?
Perfect. Please
Thank
go
you
ahead.
very much, Jana. Good morning, good afternoon, good evening, wherever you are. And now sometimes I have doubts that someone is an expert, but Roland is even much more than an expert. And his information intensity, I think you were also quite impressed. I would like to talk, give you a more a few more examples for unintentionally formed POPs and the integrated pollution prevention and control approach, also with taking into account this triple planetary crisis. So let me see. I just want to forward. Yeah, okay. So this is quickly the outline, very quickly, because Roland said most of it about the Stockholm Convention. Then the BAT-BAP guidelines and the BAT-BAP approach in Europe. And then I give you, that is my main part, relevant industrial sectors. We will talk quickly about integrated steelworks and electric steelworks, metal smelters, cement plants, and electroplating installations. And I will briefly touch also the approach of permits. And Jana just said I was also a permit writer and an inspector and an enforcement guy. So it is very important because so far we do not have something better than the control approach to give permits and to inspect it. So very quickly, unintentionally produced POPs. So this is, as Roland mentioned, that we have the dioxins, the furans, the PCBs, and so on, and that we should continue to minimize that whenever possible, and that the approach what we have, because when we say we have to reduce it, we have to minimize it, we always ask how to do it. And today now we have a quite good number, and Roland mentioned them already, the best available techniques, reference documents describing the best available techniques and best environmental practices in the different sectors. So this is, again, the best available techniques, which is now, and I will come back to this at the end. And that was also mentioned that we have now these guidelines on BAT for different industrial sectors. And in Europe, I think we have now the biggest compilation of these best available techniques, reference documents for the different sectors. So I will, in the end, as I just indicated, I will give you a small introduction how this exchange of information on BAT is happening in Europe. It will be brief, but this is important that we have now in Europe established since 1997 this Bureau for Integrated Pollution Prevention and Control. Today, then you will see in a minute, they have even changed the name. And this bureau started in 1997 with 3 people from UK, Sweden, and Germany. And I was the German guy of this team at that time. Now coming to this integrated steelworks for the different sectors. And Roland already mentioned this best available techniques reference document, a couple of copy of the front page he showed, and this is now this front page of the document for iron and steel, which was first issued in 2000, then was revised and was then issued the revised version in 2013. So it's already now the second generation of BREF documents. And he mentioned this huge release of this steel plant in Taranto in south of Italy. I also was there many years ago, and it's quite amazing how much they emit. And if you have an integrated steelworks, that means we have a sinter plant, we have coke oven plant, we have blast furnaces, and we have basic oxygen steel making. And from the sinter plant, mainly we have the dioxins and also the PCB, whereas the benzene and polycyclic aromatic hydrocarbons, the PAH, and also lead and chromium and mercury is from the sinter plant. And the PAH and benzene is from the coke oven plant. And even at that time, the workers were complaining to me that it is very hard to work there. But it is not only, as Roland indicated, the workers, it's now a huge area which is impacted by the emissions of this integrated steelworks. And of course, it is not the only one. At other places, we also have still issues, although we discuss it now for decades. So here, this is what Roland already showed. For the emissions to water, we also have this. So they have also the coke oven wastewater is a major source for the PAH and also for the phenols and also for some heavy metals for the emissions to water. And it is very important to really tackle the wastewater from the coke oven plant, which is difficult to tackle, but we can tackle it. And still, in the meantime, now we have also the biological treatment of this, but it really takes experience to run such a plant smoothly, because you have also inhibiting compounds in the wastewater from the coke oven plant. Then this is an important hint from China, and that is what Roland also indicated. If we have unintentionally formed POPs, that is one thing, but we should never then forget about other pollutants, especially heavy metals. And that is just this example from a lead poisoning Chinese metal smelters, which you can see. It's already from 2009, but it is still valid and actual, and you can also then look in more detail to this. Then electric steelworks is a huge source of uPOP, but also of heavy metals. Also, this is covered by the document on iron and steel, and the latest, as I told you, issued in 2013. And you see that these documents are quite comprehensive. So 600 pages is the iron and steel brief, and I think the maximum is now more than 1,000 pages for one sector, non-ferrous metal processing, for instance. And here you see a steelworks, and this is a steelworks in Germany, producing today now about 2.2 million tons of carbon steel. And if you look at the emissions to air, it's really amazing how high it is. And still mercury, you see they still emit more. They emit almost 2 kilograms per day. And that is quite a lot. I do not know any other source where you still have such a high mercury emission. And we have in Europe quite a number of electric steelworks still, but also lead is relevant. You see 167 kilograms of lead per day. And also important is this organic nickel compound, nickel tetracarbonyl, which is quite high, and it's more than 1 ton per year. Highly toxic. Also, and you see now I started with the heavy metals, but of course the unintentionally formed POPs, the dioxins, the PCB, and the hexachlorobenzene are also relevant. You see here 1 kilogram of hexachlorobenzene, that's quite high, and even 10 kilogram of PCB. This is a lot, and that's why, and Roland indicated that for Switzerland, it's very important to remove the dust as much as possible. And you see in this plant, they are really achieving best available techniques. If you have a dust concentration of less than 1 milligram per norm-meter cube, this is very low. And what they really achieve is constantly less than 2 milligram per meter cube, even less than this. So that means here, the most important thing first is to collect the dust, and you should have the dust collection efficiency more than 98%, because also a lot of dioxins and the heavy metals are related and adsorbed to the dust particles, and that's why this is very important to have the dust control. And I have to tell you, this is quite exceptional to reach such low levels. But if you do that, and it is possible, and it is also economically viable to do that, and what they have is a very well-designed backfilter house, and so you cannot achieve that with an electrostatic precipitator. For this, you need really a well-designed backfilter house to remove this dust, and that means at the same time to remove most of the heavy metals and also because they also adsorb to it a quite high percentage of dioxins and furans and PCB and hexachlorobenzene. Just to say that. So this is what Roland already said, so I will not repeat it, that when we do considering such facilities like the electric arc furnaces, we should not only look at the organic POPs, but also to the heavy metals. And that is the intention of this UNEP document Roland mentioned already. So to see how it developed, so it is not so big. So the first document, the first BREF document for iron and steel was issued in 2000. And that was the first document which was published, and I was the author of that. And then 13 years later, there was already the revision available. And if you see now the dust, the collection efficiency, 98%. And at that time, in 2000, we had 5 milligrams for new plants, 50 milligrams for existing plants. After the revision, we say BAT is to achieve less than 5 milligram dust per norm meter cube. That is quite low, and you have seen that this plant I have just shown you, and I will show you the emission curve for 3 years in a minute. Before doing so, I show you also the values, which are called BAT, associated emission limit values. That means the emission limit values associated with the application of BAT. And in 2000, it was less than 0.1 to 0.5. And now in the revision, it is less than 0.1 nanogram toxic equivalents per norm meter cube. And the abatement techniques are also described. And that is important, that you should have all these installations, like the electric arc furnaces, should have an online monitoring system. Here you see just a photo to have online measurement of dust, of NOx, and also of mercury, very important, because and also of VOC, to see that the abatement system is really working and to measure it. So here you see now a 3 years emission curve of all the daily mean values of this plant I have just shown you in Germany. And you see here in this year, they had some higher values, but this is still less than 5 milligram per meter cube. And here you see they have most of the time around 1 milligram dust per norm meter cube. Even here it's a little bit lower. So this is really a well-operated back filter house with an online measurement, and whenever they have any break maybe of a filter, then they can stop it. They have different fields, so they can take out of operation one field, can repair it, and the rest of the back filter houses still has enough capacity to completely remove, or almost completely remove, the dust. If we look at cement plants, I would like to take your attention to this. So this is also a document with almost 500 pages. Here you see also, like for the others, you see the source. You go to this bureau for doing this, publishing these documents, and it's I show you, and it's for free. You can go there anytime. You can download it, and you find all these best available techniques, BREF documents, as Roland said, here at this website. What I want to show you is this co-incineration of waste in a cement kiln. And very often I hear, yes, we have more than 1,200 degrees. We have a retention time of a couple of seconds. So any organic contaminant will be destroyed and no dioxins are formed. Correct? If you talk about the main burner. Every fuel which is then charged here via the main burner, I will show you in a minute that there are different fuels to charge here. Then you have in this kiln, you have these conditions, very high temperature, more than 1,200 degrees up to 10, 12 seconds retention time. So no organic, no dioxins will be formed, no emissions from there. But we have also the secondary firing. Sometimes just they put fuels into the kiln inlet, and we call this part the kiln inlet. That is number two. This, if it's okay if you do it properly. If you do not do it properly, then you can really have increased emissions from this part. And here you don't have this high retention time, high temperature as you have it in the kiln as such. If you put some raw materials and contaminated raw materials to the, or materials to the raw material, and this raw material then is slowly preheated here in the cyclones, here you can have then a purge of all volatile compounds, and then you can have very high emissions if this waste which you put to the raw material is contaminated. I will give you an example in a minute. Before so, just to show you how it looks like before the main burner, that you have different pipes where you can charge plastics, additional air to the plastics, sewage sludge, then distillation residues, heavy oil, in case you still need coal, then some coal. So you see, you have different types of wastes which are charged here to the main burner, and there no issue with respect to emissions to air. But for secondary firing and the raw meal way, we really have to pay attention. So here you see also a photo, and it's like this. In Germany, for instance, a couple, around 10 cement plants are fully running 100% on waste-derived fuel, so they don't use anymore any fossil fuel, no coal. And but we have to make sure that the co-incineration is done in a good way. So I show you now an example here from the raw material way, so that a waste was given to this raw material, and this is then slowly from ambient temperature heated in the cyclones. And then doing that here, you have then several hundred degrees Celsius, but then any volatile compound will be purged and will then go with the flue gas coming from the kiln, which is going this way because we have a counter current preheating here, but the flue gas is coming from the kiln, is going this way, and the raw material is coming this way. And if you have some waste in the raw material which has volatile compounds, this will leave the system with the waste gas from the kiln. And that is just to tell you again, for the secondary firing, you can have just in the kiln inlet a discharge. Better is to have really a burning chamber as a calciner, where you have controlled conditions for the co-incineration, and that should be much better than this. That means if you can do it with a secondary firing, but you have to do it in a technically sound way. So this is a plant in Switzerland, and there was a massive hexachlorobenzene contamination in 2014 because they had some waste from a landfill, which is containing mainly lime. So they thought, okay, this we can use as a raw material, and they mixed it with the raw material, this waste, and then all the hexachlorobenzene, which was in this waste, was evaporated, was volatilized, and they, at that time, the whole valley, because this is placed in a nice valley in Austria, was completely contaminated. All the fodder, the Fabian, the meat, the milk, the animals, everything was contaminated. It was a disaster and a big case, and that is just to inform you. Be careful with cement plants. Never do waste with a raw material way, and for the secondary firing, you have to pay attention, and for the main burner, you can say, okay, that's fine. Then I give you an example about surface treatment. So this is not because before I come to this, just to tell you where we are, that means I told you that the start of this developing of the best available techniques reference documents was in 97. Then it took, when they started, I think early 2000 something. And then in August 2006, the document on surface treatment of metals and plastics was issued. And since then, it was not revised, and it is now currently under revision. And last year, we had the first draft, we call that D1, was issued in February, just 1 year ago. And still now, a lot of comments have been submitted, and these comments are now processed. And then this year, it is expected then that the second draft, this is the final draft, D2, will be issued. And you see this document is already almost 1,000 pages, 930 pages, quite a lot. And where you find it again, this is indicated here with a source. I have taken now one example, which is not an example for a persistent organic pollutant. But as Roland said, we have to have an integrated view. We should also look at compounds which may have an acute toxicity. And this is now a so-called, it's called dimethyl dithiocarbamate. You see now the structure of this small molecule. And this is an organosulfide because you see the two sulfur atoms in the molecule. So here, and that's why we call it organosulfide. This is used in electroplating industries to precipitate heavy metals to a very low content. So it's in principle it is applied for environmental protection, but it is also very cytotoxic. It is a broadband biocide. It's very toxic to bacteria, especially to nitrifying bacteria and also algae. So if there is an overdosage or maybe an uncontrolled release, then you really have an issue. And we know that this compound is very often discharged in Germany also to municipal wastewater treatment plants. And there we have from time to time really severe nitrification issues. So here you see just a few the values of algae toxicity, fish toxicity, very low. Biodegradability, there is inconsistent information, but it is not persistent as such as we have it for the POPs. So we had then a huge fish kill in 2014 because one electroplating industry was discharging this compound. The municipal wastewater treatment plant, the biological stage was completely inhibited. That means then a lot of ammonium was discharged and also nitrite was discharged, and nitrite is very fish toxic. And there was a sampling of the sewer biofilm, just to say that if you want then to locate such a company, one issue now, or one option is really to look to sample the biofilm in the sewer system, because then you can say from this area it is not coming, it's coming from this area, and then you end up usually then with a source. And in that case, it was clear an electroplating industry with an uncontrolled overdosage of this organosulfide, which was creating that. So here we saw that in the discharge of this plant, of this municipal wastewater treatment plant, a lot of foam, the dead algae in the biofilm of the discharge pipe, which is usually green. So everything was killed and also the fish was killed. So that is then with respect to triple planetary crisis, it's also a type of pollution of acute toxicity. And I just wanted to mention that as an example, even it is not belonging to uPOPs, I have to admit. So then for what I announced already, that this type of permitting, so this providing permits and to do the enforcement of inspection enforcement of permits. So far, we do not have any better approach rather than this permit-oriented approach in the world. We were discussing a lot in the past, and we had also some voluntary schemes, but in the end, we saw that it is not working. Also not in Germany, if you would say the awareness is higher than maybe in another country, but also there it is not really working. So we need this law and order approach somehow. And what we have today is that every installation has to apply for a permit, and the competent authority is then checking everything and it is granting the permit. And what I would like to recommend is that maybe many of you should just have permits, maybe translated, for instance, from Germany, from other parts of Europe, so that you have some model permits, how it could look like, how to regulate, how to write the permits. I do that for the moment with India, and they were very happy to see, okay, this is really helpful that we have maybe a basic structure and how deep we go, not just only end of pipe values, but also maybe some conditions concerning the use of certain chemicals, that certain chemicals should not be used. Roland has already mentioned the elemental chlorine, and we should not use anymore for bleaching of pulp, for instance. And for instance, one condition would be use only hydrogen peroxide for bleaching. And for textile industry, for leather industry, a lot of things can be done to regulate that in the permit. And such a permit should take all the aspects and pollutants. That means not only the uPOPs and the POPs in the Stockholm Convention, but also other aspects like particulate matter or the heavy metals, what we have mentioned. It, of course, has to respect the IED directive, but also other EU directives, and also the Stockholm Convention and the Minamata Convention and the UNECE Protocol on long-range transport and so on. So that is important, that the competent authority really has to be competent in order to be able to issue really good and enforceable permits. So today we had different authorities for the industries. Today we have one authority for one industry. In some parts of Germany, for instance, we have up to 3 authorities still competent for one industry. So, and we do have still some time.
You still have 3 minutes, Professor.
Okay, that's enough. That's enough. We have talked about already the BAT, and that the emission limit values should be based on BAT. And this is also said in the Industrial Emissions Directive, IED, which was issued in 2010 and was revised in 2024. And I will not go now to that is just the definition of what are best available techniques. Just to say, sometimes people understand best is the best of the best. It is not the best of the best, because we have to respect the economic viability and the technical feasibility. So the economical part is also taken into account, and that means in the end we decide what BAT is. It is not the best of the best, but it is the best combination of technical feasibility and economic viability. So the European Commission organizes the information exchange on best available techniques in the European Union, and the result are these best available techniques reference document. And we have for this, we have these working groups for each and every technical industrial sector. We have a working group, and so far we have 38 installed. And this European Bureau for Research on Industrial Transformation and Emission, they have changed the name. Before it was the European IPPC Bureau. IPPC stands for Integrated Pollution Prevention and Control, and all member states, industries, environmental NGOs, universities, research institutes are invited in these working groups to give their input and to have then really good documents which are helpful. And so far we have now 38 documents, and 5 we have so-called horizontal documents for monitoring and energy and cooling systems. And then we have the so-called vertical documents for the different industrial sectors. So just having said that, I thank you for your attention, and maybe in the meantime, there was a question, and I'm happy to answer if we have some time for that. Thank you very much. To say it is, of course, a collaboration work with Roland together, and you see that that's why we are the 2 authors of this presentation. Thank you.
Thank you so much, Professor Schoenberger. And yes, there are some questions, but I think some of them have been answered in your presentation. So in the interest of time, I will give Dr. Raber back the floor for options for action plan activities to control, manage.
Gehst du raus mit deiner Präsentation?
Sorry, go ahead.
Yeah. No, I have to stop my presentation, so because it's blocking Roland.
Okay.
Okay, now it's fine.
Okay, Roland, back to you.
Good. Yeah. Thanks, Jana. Thanks, Harald. So the last presentation today is on PFAS and on action plan option activities to control and manage POP-PFAS, and with the synergy with the global framework on chemicals, also to look to the larger issue of concern of all PFASs. So meanwhile, we have 4 groups of PFASs listed in the Stockholm Convention: PFOS, its salts, and PFOS-F, PFOA and related compounds, PFASs and related compounds, and recently the long-chain perfluorocarboxylic acid have been listed in 2025 and will come into force end of the year. When you consider that each have around 200 related substances, so these are already, let's say, more than 600, 700 substances regulated from these PFASs. So therefore, PFAS will become more important for the implementation of the Stockholm Convention, but also it is really important to address them, because PFAS pollution have crossed planetary boundaries. There is a publication from Cousins et al. From 2022 that the 4 PFASs, PFOS, PFOA, PFAS, and PFNA, mean all are in the convention, right? It has been concluded that the global spread of these PFASs has led to planetary boundaries exceedance for PFAS pollution, because the levels of PFOA and PFOS in rainwater often greatly exceed the US EPA lifetime drinking water health advisory. And also the sum of 4 PFASs in rainwater is often above the Danish drinking water limit values. So this means, yes, drinking the rainwater would be above the drinking water limit in some areas. Also, levels of PFAS in rainwater are often above environmental quality standards of the European Union for surface water, and the atmospheric deposition lead to global soil being ubiquitously contaminated and to be often above the proposed Dutch guideline values. So these are the background why the Cousins concluded we are above the global planetary boundaries. And for PFAS, we are not talking about decades in degradation, but we are not sure if they are degrading in the environment over centuries or millennia. Yeah, because if they are in groundwater or in the soil, there is not really known degradation. PFOS has been substituted the last 20 years, and also PFAS production stopped in 2022. Also, PFOA and related compounds have largely been substituted in different regions. In many uses, we still have some exemptions, but due to their very high persistence, most are still present in the environment, and especially in reservoirs like landfills. There is a recent publication from China. They have evaluated all landfills in the world, and they estimate also that more than 100,000 tons of PFOS, PFOA are in the landfills. Yeah, and because of their water solubility, they will make us trouble for the next centuries to come. So, yes, many POP-PFASs have already been substituted, but industry moved to short-chain PFAS and PFAS ethers. Today, we have more than 10,000 PFASs on the market. Yeah, I just show you here some examples. And there was a recent publication about PFASs in PubChem, that they are now around 7 million PFASs listed in PubChem, and that the numbers are growing. Yeah. So also here, let's say from our Stockholm Convention, we have addressed often only the tip of the iceberg. What is good is that when we look to the close link between POP and the global framework on chemicals, and the global framework on chemicals have listed all perfluorinated and polyfluorinated alkylated substances and the transition to safer alternatives and chemicals in products, that we can address with this synergy also the larger frame of PFASs. There are also other issues of concern linked to PFAS. One is about highly hazardous pesticides. When you look to our GGKP webinar from December, you see that there are PFAS pesticides and PFAS degradation products, mobile degradation products like the trifluoroacetic acid. Also, there are environmentally persistent pharmaceutical pollutants, which are PFAS. Here, the perfluorooctan iodine and perfluorooctan octylbromide. So, let's say with this synergy, here the specific POP issues can and should be addressed within the larger frame of managing an entire group of substances. This means all PFASs with a science-based approach. So why did the global framework on chemicals consider all PFASs? The reason is also concern on short-chain PFAS due to persistence, high mobility, accumulation in plants and vegetables and fruits, and difficulty to eliminate short-chain PFAS in drinking water. So while the POP-PFASs are quite bioaccumulative, and let's say the toxicity is already much better discovered than for the short-chain PFASs, the short-chain PFASs also have big challenges in management because of this. So all short-chain PFASs are highly persistent or have highly persistent degradation products which are water soluble and are a risk to water and plant, vegetables and fruits. Their persistence in the environment is irreversible, insufficient data on structures and toxicity, and considering the need for the synergy between Stockholm Convention and the Global Framework on Chemicals, the action plan for POP-PFAS could also address all PFASs as appropriate. I recommend here to use here the OECD definition on PFAS, and I have included it here also with a link. First, again, action plan in respect to regulatory framework for listed POP-PFASs and other PFAS. Objective is to establish policy and regulatory frame for the use, management and substitution of POP-PFASs and possibly other PFASs along the life cycle. Recommended activity options are assessment of established regulatory frames for controlling POP-PFASs and related compounds and other PFASs. Here I recommend you to look to the EU regulation and also possibly to the Australian regulation. The OECD had a webinar where some countries presented on their regulatory frame. Then to amend existing laws or develop new laws related to the restriction, control and management of POP-PFASs and related compounds, and also possibly regulate all PFASs. Consider in the regulatory frame the exemptions needed for PFOS, PFOA or the long-chain perfluorocarboxylic alkylated acids improvement of the traceability of chemicals and chemicals in product, and custom control, here linked to GHS as a GFC synergy. Option 2, require labeling of PFAS in products. That would help a lot with the management. Establish extended producer responsibility and polluter pays principle for POP-PFASs and related compounds, and also for other PFAS as a group. So we have published in 2015 the Madrid statement, the Madrid Science Statement on PFAS. This is a document which compiled the scientific consensus regarding persistence and potential harm of PFASs, and lay out a roadmap to gather needed information and to prevent further harm. And here you can find recommendations to policymakers, industry, and science. And already at that time, we have suggested to regulate and manage as a group. PFAS as a group has been signed by more than 200 scientists. And what was good is that it was with a dialogue with the fluorine industry, the Fluoro Council. This means we have published it, and in the same issue of environmental health perspective, the industry could comment on our recommendation, on our Madrid statement, and then we could comment on their comment, and again they commented on our comment on their comment. Unfortunately, currently the DOIs of environmental health perspective articles do not function, since environmental health perspective was closed due to budget cuts of the Trump administration and now formally transferred to ACS. Also, there is another publication which gives more detail about regulating PFAS as a group, and I have put you the link to that. Another request at that time was, or suggestion from the Madrid statement, is to enact legislation to require only essential uses of PFAS and enforce labeling to include the uses. And later, the European Commission, in its chemical strategy in 2022, they also suggested to address PFAS as a group with the following action: phasing out the use of PFAS in the European Union unless their use is essential. Yeah, and here now you have a complete proposal of a regulatory frame. So in 2023, European Chemical Agency published details of a proposed restriction of around 10,000 PFASs. That's available on the European Chemical Agency website. And they received 5,600 comments and included these comments, and just in August 2025 published an update. And this is an ongoing assessment, but this is what I said is interesting for countries to look to that regulation. Related, another publication which defines what is the essential use concept. I don't go into details, but you have the link, and there you can look into essential use concept. And in my opinion, this is very useful, not only for PFAS, but also for plastic. And it really relates to responsible consumption and production. This means SDG 12, because overall, especially in our consumption society, we need to reduce overall production and consumption, not for the developing countries. Objective second is always the inventory. Update and refine the inventory of POP-PFASs and other PFASs and PFAS-containing products, PFAS waste, including a database for information management. The recommended activity options are to develop and refining inventories of POP-PFASs and other PFASs in firefighting foams. Many countries have started it, but it is also not that easy. Develop or refining inventories of POP-PFASs and other PFAS in consumer products, treated synthetic carpets, textile, furniture, paper, transport sector. Developing or refining inventories of POP-PFASs and other PFAS use in industry. Refine the inventory of stocks and waste of POP-PFASs, including landfills. Refining inventory of historic use and releases of POP-PFASs and other PFAS, and possibly do a material and substance flow analysis. I find this quite good for policymakers, because on just one page you get an overview on such inventory and the related flows. The regulatory frame and action plan should address POP-PFAS in the life cycle. Control of recycling becomes increasingly relevant as countries move towards a more circular economy. And POPs, including PFAS, are frequently in such products which are recycled. Also, PFAS end up in sewage sludge, which is applied to agriculture. So it's also a kind of recycling, but a big scale recycling. And what we have found now in Europe is that for this reuse or recycling of these biosolids on agricultural fields, we have contamination not only of the fields, but also of our cows and milk and meat. Third is on the life cycle management of products, stockpiles and waste containing POP-PFAS. Objective is knowledge and capacity is built for the management of products and waste categories containing POP-PFAS and other PFAS, as well as environmental sound management of PFAS is implemented. The recommended activity options are compilation of information of management situation of products and waste containing POP-PFAS and other PFAS in your country, assessment of the management and destruction options of product stocks and waste containing POP-PFAS and other PFAS, then the environmental safe storage of the waste, assessment and control of POP-PFAS in affected recycling cycles, including sewage sludge, destruction or export of POP-PFAS containing waste, and including the environmental sound management of other PFAS containing products. So this is actually also a contemporary challenge even in high income countries, because the question is really how can the world destroy PFAS containing waste in an environmental sound manner? If we put PFAS to landfills, they are leaching. This means it's only a matter of time, but because they are water soluble, they migrate slowly and finally they go out in leachates. Therefore, yes, landfill is not an option for PFAS. Monitoring waste incinerators operating mostly below 900 degrees can currently not be considered proven for destruction of PFAS. And here the US Department of Defense stopped the incineration of PFAS-containing firefighting foams in 2022. Actually, they were forced to stop the incineration, and they requested the US EPA to develop a guidance for PFAS destruction. Yeah, US EPA developed the first, did an update in 2024. I recommend you to have a look, but there you see how challenging it is. Hazardous waste incinerator demonstrate that at a temperature of 1100 degrees is sufficient to destroy POP-PFAS. However, there is still an uncertainty in respect to the carbon tetrafluoride, because this can be formed in the degradation, and this is only destroyed around 1400 degrees. However, hazardous waste incinerators are quite expensive and mainly available in industrial countries. Also there, they are normally not so frequent, so it's quite expensive and the capacity is limited. So overall, also in our countries, we have a challenge in industrial countries to really destroy PFAS in an environmental sound manner. One alternative facility is here the thermal destruction in cement kilns. And I think that this is an option. Actually, cement kilns like fluorine and fluorides and has appropriate temperature. So this could be, let's say, one option in future to manage it. Here is just about the life cycle, and there you see that it's really different to the normal POPs. In the normal POPs, normally the accumulation were in kettles and fish and the exposure, but because here the PFAS are water soluble, we have much more challenges with all the reservoirs from the production of the last 70 years. And also we have a production of the whole water cycle, mean drinking water, but also the accumulation in plants, including food plants, and the exposure from food ingestion. Therefore, very important here is the assessment and selection of alternatives. The objective here of this action plan is POP-PFAS alternatives in expected and all uses are assessed by a science-based approach, and POP-PFAS are substituted by the most sustainable chemical and non-chemical solution. Recommended activity options are compilation of information on alternatives to POP-PFAS, including fluorinated and non-fluorinated alternative. Consider that the BRS Secretariat and the POP Reviewing Committee have compiled information, so that's published here in that guidance. But also we have from OECD, from ChemSec, from the European Zero PM project. This is the science community activities of developing publications or even a database here on substitution of PFAS. Then education and capacity building on alternative assessment, selection of the most sustainable alternative chemicals and non-chemical solution in the current used applications and implementation of the substitution. I give here one example. This is for firefighting foam, assessment of alternatives to POP-PFAS firefighting foams. There are fluorine-free and there are PFAS foams with shorter chain, often C6 chemistry. And then as a second step, phase out POP-PFAS firefighting foams and possibly phase out all PFAS firefighting foams. This is at the moment happening in Europe. Europe has just published the EU guidance for transitioning to fluorine-free firefighting foams, and I have put you the link here on the slide. Then when you go to this transition, one activity need to be cleaning firefighting equipment, including fixed installation when substituting, because otherwise when you take out the POP foam and you refill in another foam, you get a cross-contamination, and therefore you should include the cleaning of the equipment. Assessment of destruction option for POP-PFAS and other PFAS containing firefighting foams. There is one case study from Australia. There you can look for the Basel Convention. I think it's published there. Also recommended for the alternative assessment, science-based assessment, if any exemption of POP-PFAS production or use is needed. If you find that you need some exemption, then one activity is notification of the BRS Secretariat and the Conference of Party of the needed exemption with appropriate information. And the information is here: what exemption, estimated quantity of products and use, purpose of production, and the reason for exemption. And then one activity should be a periodic review to assess the need for continued exemption and assess alternatives. Stop the exemption and use by more sustainable alternative as soon as feasible. Then the fifth objective and action plan part is on BAT-BEP in the needed exemption. So here, if POP-PFASs are produced or used in exempted uses, then BAT-BEP need to be applied for controlled production and use and to prevent releases. Also to ensure the environmental sound management along the life cycle of POP-PFASs. Recommended activity options are define and implement BAT-BEP for production of PFASs, including release limits, and develop related control, production, release, and waste. Define and implement BAT for the use of PFASs in industries, including release limits, develop related control of uses, releases, and waste, and require the retention of firefighting water considering the UNECE guideline, because firefighting water, many of the contaminated sites come from this firefighting foam release. So there is the option to try to catch as much of the wastewater and to manage it. And there is the guidelines, and I have put you the link there. Labeling of products containing PFAS and capacity building of industries and firefighters on BAT-BEP and how to minimize PFAS use and release. Then education, training, and awareness raising for the stakeholders. The recommended activity options are inform and sensitize policymakers on health hazards of PFAS and the related risk for humans, the environment, and for drinking water, food security. Awareness of industries on the health risk and on potential cost of future remediation. I will show a bit. Awareness of the public on health impacts and environmental pollution, as well as alternatives of consumer products without POP-PFAS and other PFASs, especially here for textiles. Development of related education and awareness material, dissemination of information, including the alternatives. Then inform and sensitize policymakers on health hazards for drinking water, food security, and the need for management, awareness of industry and on potential health cost. And I show here this health cost. The update of drinking water, the cost of drinking water works. The upgrade of drinking water works in the United States to comply with the suggested drinking water limit is estimated to 74 billion US dollars. The cost to remediate legacy PFAS and ongoing emission in Europe is estimated to 100 billion euro per year. I have also put here the link to that study. So they have calculated two different legal scenarios, which is about just on the POP-PFASs and their restriction and phase out and management. This is around 100 billion over 20 years. And the emerging scenario, which is considering also other PFASs, the short chain, the cost is estimated for 2 trillion euro over 20 years. This is the 100 billion euro per year. Yeah. So therefore, you also see how important it is to look not only to the POP-PFASs, but to others. And for awareness, just a few slides on contamination of drinking water. In 2016, the publication for the United States, considering the health advisory of 70 nanogram, estimated that 6 million US residents were exceeding US EPA lifetime health advisory. But then the Center of Disease Control and also the European Food Safety Association said that this is still 10 to 100 times too high. So today we have much lower drinking water limits here for Danish EPA, 2 nanogram per liter. The US EPA interim health advisory for P4 is 0.004 nanogram per liter. When you consider for the United States, 10 nanogram per liter, around 18 to 80 million people are above the limit. When you consider 1 nanogram per liter, then over 200 million people in the United States are over this drinking water limit. So you see how many people are affected. We have done the same for China. A friend of mine, Professor Jun Huang from Tsinghua University, compiled here all the data from publications for 66 cities in China with 450 million inhabitants. And the PFAS concentration of more than 20% of the studied cities were above maximum contamination limit, affecting around 100 million people. Likely several hundred million people in China are above the Danish drinking water limit of 2 nanogram per liter. This shows that a large number of people are affected by PFAS contaminated drinking water, but there is a lack of monitoring, so we don't know the situation of other Asian countries. We don't know the situation in Africa or Kulak, but I'm sure that also a considerable share of the population will be above these limits, and therefore the authorities need to react. Assessment, management, and database of sites potentially contaminated, and they are related to this drinking water contamination because often they impact the water reservoirs. So here the recommendation activity options are develop, update legislation to set criteria for determining contaminated sites and legislation on liability related to contaminated sites and cleanup, developing guidelines for identification and assessment of sites, contamination with POP-PFAS. This here is the German guidelines. We have the government developed different ones. Training in identification and management of PFAS contaminated sites, developing a database and map of potentially PFAS contaminated sites, and then do a prioritization. And this is a publication about a methodology, how to develop a national map of potentially PFAS contaminated sites and go to the main contamination sources. These are these firefighting foams, certain industrial facilities like chromium plating or paper industries, and then sites related to PFAS containing waste, including wastewater treatment plants. So here for the United States, it was estimated that there are 57,000 potentially contaminated sites. A similar assessment has also done for Europe. We have around 40,000 PFAS contaminated sites, 20,000 sites confirmed and 20,000 sites presumed. So then the next step is monitoring of POP-PFAS and other PFAS contamination for the identified locations according to a prioritization list. develop guidelines and strategies for environmentally sound management of such sites. Like I said, Germany has developed, but also other countries, and we have the BAD-BEP guidance for contaminated sites from Stockholm Convention. Then take measures here to secure contaminated sites, identification of cleanup measures, and initiate cleanup, especially high priority sites where drinking water, for example, is contaminated. Here I have one page where I have put some of these guidance documents with the links for you. And I think that's already the last activity is then on developing analysis and monitoring of POP-PFASs and monitor PFAS in priority areas. Here, the recommendation activity options is assessment of options for monitoring POP-PFASs and other PFAS. Also here we have the problem that most developing countries don't, or almost all developing countries don't have the capacity of PFAS analysis. Therefore, also looking into international collaboration or develop our own capacity, but it takes time and it is costly. Estimating a monitoring frame for POP-PFASs and other PFAS. Then monitor first major drinking water supplies in the country and improvement of the inventory by monitoring where knowledge gaps have been found, including monitoring of products and articles, monitoring biota and soils, and biota also including cattle and livestock, especially at potentially contaminated sites. And one monitoring which is relevant for inventory is also the monitoring of firefighting foams. Also here, many developing countries, they have looked into their stocks. They found AFFF foams, but often it was not clear, is this POP-PFAS or is there any PFAS in it? So I give here a good case study. This is from Thailand. Thailand has developed a guidance on the identification and registration of firefighting foams containing POP-PFASs. And also in Thailand, they have developed in a UNIDO project the analytical capacity and are analyzing these firefighting foams. So this can be seen as a best practice study. And then another best practice study comes here from South Africa. So here, Professor Okonkwo from Tshwane University monitored major drinking water of whole South Africa, that the government understand where there are problems and where they have to reduce emissions. Yeah, thank you for your attention. And now we can come to the questions.
Thank you very much. Thank you. Thank you very much, Roland and Professor Schoenberger. Really intense, really information dense. I think in the interest of time, you can see, and all of our colleagues here also, we have 6 Q&A questions posted.
Yep.
You may also choose to type your answer there, but between Sumin and I, we thought we would highlight 2 just for discussion. And if they're still here, Mr. Elham Aziz. There's a question about the standard procedures in Germany for the safe handling, disposal, or recycling of firefighting foam cylinders containing PFAS and PFOS, immediately following the last slide of Dr. Weber. Would you like to answer that, or we can follow up with a written response after?
No, I think we should answer some of the questions. Yeah, I think it's useful. Yeah. No, so yes, in Germany, you know, we have hazardous waste incinerators. So therefore, these kind of firefighting foams, they are going into hazardous waste incinerators. And the second thing is what I showed you before is in Germany, we have around 5,000 fixed installations containing firefighting foams. And these fixed installations before, more or less, most of them contained POP-PFAS firefighting foams. So what is happening at the moment in Germany is we are substituting this firefighting foam there. Yeah, so the firefighting foam is then incinerated. And also the water from the rinsing and cleaning of this equipment is kind of precipitated, yeah, and then used an adsorbent that you don't have to incinerate all of the water, yeah. So this is at the moment the procedure in Germany, and I think from the 5,000 equipment, we have now substituted and cleaned a bit more than 1,000.
Interesting. Thank you so much, Dr. Weber. Now, there is one question early on in the discussion from Mr. Robert Whitting, who's working in the UK for Annex C emission inventories. For the emissions associated with power generation, he assumes to an extent that this is linked to energy from waste or burning waste in incinerators for energy production. Any comment on that?
No. So waste incinerators and waste to energy is not in the power field. So waste incineration stays in the Stockholm Convention also as waste incinerators. The power plants are often coal power plants, worldwide. Also coal power plants, depending on the chlorine content of the coal, can have a relevant dioxin release. So in the inventories, the dioxin emission of the power plant is normally not of the co-incineration of waste. Yeah. Also, cement plants normally stay cement plants also when you have co-incineration there.
Got it. And maybe this next question is for Professor Schoenberger. Mr. Kiao Moong asks, is biochar a potential solution to remove heavy metals, arsenic, and other uPOP and PFAS?
I have to give you an answer of a lawyer. It depends. So biochar has very good properties to do adsorption, but what you then can adsorb, which type of metals, in which form, and which POP, it has to be investigated. But in principle, it is a good substitute for conventional activated carbon.
Thank you so much. I think we have time for one last question before we wrap up.
Yeah, wait. So Olga Speranska is asking about metal industries in East Europe and Central Asia. So the data which are compiled there, these are from the national implementation plans. So Olga, you need to go to the individual countries, to national implementation plans, or maybe Dr. Fiedler compiled those data from that time. So possibly there is already a compilation which shows for the individual countries what emissions. Yeah, otherwise they should be in the NIPS, they are in the dioxin inventory. Then there is Shirila Whitelock-Billingish. She asked about the dioxin limits for soil and if this is specific of soil conditions and locations. It's a complicated question. So normally, let's say there should not be a too big difference. But what we know is that when you have dioxins which are, for example, coming from a facility emitted together with activated carbon, they are less bioavailable. So this means this soil where you have then the dioxins adsorbed to that kind of carbon might be less problematic compared to, let's say, when we go to Seveso, where the dioxin were directly released to 2378 into the soil, therefore really bioavailable. And then you have also different degradation. What we see in Vietnam is that for some areas where 2378 has been sprayed in the Vietnam War 50 years ago, the 2378 in some of the soils have degraded to some extent. While what we see here in Germany, we have factories from 150 years ago, and I do not really see that there is a degradation when I consider the dioxin pattern. Yeah, let's say this is, I would say, as a different, especially when you have high activated carbon, let's say it might be a bit less bioavailable. And there is also a remediation strategy to mix soil with activated carbon, for example, and see if then afterwards the bioavailability has decreased. Stefan Robinson is asking, where do the used backfilter goes? Is a very interesting and good question. I think that the backfilter from a waste incinerator really have high dioxin levels. I have analyzed some of them while I did dioxin analysis 30 years ago. So if you have a normal backfilter, I think it can go into the incinerator. One big question mark I have, if the backfilter is made out of Teflon, or other fluoropolymers. Yeah, because there, if you have a normal municipal waste incinerator, I would not feed this big amount, and I think they might go rather into a landfill.
Wow, thank you so
Into
much.
a hazardous landfill.
That's a very interesting point, and I think thank you so much, ladies and gentlemen. Can we give virtual applause to Professor Schoenberger and Dr. Roland for all of these very, very insightful comments? Now, once again, we will continue this conversation. There is another webinar happening on Thursday. Please sign up for that. Sumin has dropped it in the link. Thank you so much for your patience. What a great turnout we had. We reached 130 participants. And now we still have at least 85 people on the call. So thank you so much for your interest and your dedication. So to continue this, may I take the opportunity to mention that the NIPS community of practice in the Green Forum is available, and Sumin will also drop the link there so you can sign up. Professor Roland, Dr. Roland and Professor Schoenberger will be there to also answer questions that you may want. So it's very active. And it would be great to know how it's going in your countries. Again, this is for National Action Plan, so we would be very interested to know what you're doing. And of course, we are all connected in the world, so it would be great to know and learn from each other. Finally, it's a gentle reminder that this is just the second in the series. So we look forward to see you on the Action Plan Series 3, Activity Options for Action Plans for Brominated, Chlorinated, and other new POPs this Thursday. Do sign up for that if you haven't had yet. So on behalf of my colleagues in GGKP and the entire Global NIPS project, thank you, Dr. Roland and Professor Harold, and all of our colleagues. Have a great evening, morning, and day. Bye.
Yeah.
Bye.
Yes.
Thank
And best
you.
wishes to all participants in your NIP development and implementation.
Thank you.
Bye bye.
Bye bye.